Okay, in this section we're going to be solving word problems, but the directions tell you to use a system, which means to use two variables when you're solving the equation. So if you read the problem, we're talking about 8 pens and 7 pencils cost $3.37. 5 pens and 11 pencils cost $3.10. So let's let the pens be X and the pencils be Y. And then try and set up a system that represents this problem. It says 8 pens and 7 pencils. So how about 8x plus 7y equals 337. All right, we need a system for the second part. 5 pens and 11 pencils. What do you think? Stop the video and write your equation first, and then check. Okay, here we go. 5 pens plus 11 pencils equal 310. All right, now all I have to do is solve the system. So I check. If I straight up add, does anything disappear? No. Okay, so I am going to multiply the top and the bottom by a certain number. I'm going to multiply the top by 5 and the bottom by 8. And this way, I will get the system. I think I'll multiply the bottom by minus 8. And this way, I will be able to get the x variables to disappear and solve the system for x. And then I can plug that in and solve for y. All right, let's get started. Okay, so let's go about solving this system here. Adding the x cancels out. I get negative 53y equals negative 795. Divide by negative 53, and I get y equals 15 cents. And if I plug that into the original, I'll get x equals 29 cents. And there we have the cost of the pens and the pencils. Okay, here's another problem. Mike has a jar of red and blue marbles. There are 32 more red than blue. And there are a total of 180 marbles. So, again, to find out how many red and blue, I need to set up a system using x and y. So let's use red equals x, blue equals y, and there are 32 more red than blue. So in this one, since they don't add up to 32, I have to use a subtraction. So how about x minus y equals 32? Now, what's important here is you need to make sure you put the bigger number first. And there are 32 more red, so I know red has more. So that's why I put the x first. So read the problem carefully. There are a total of 180 marbles. So the red plus the blue is 180. All right, here we go. I got a system to solve. Oh, this one's nice. Straight up addition. What happens? 2x equals 212. So x equals 106. So, how many red marbles are there? Red is 106. Blue, I'll let you figure that out. So, in the word problems you're going to solve for tonight's homework, make sure you use two variables to solve them. I know you know how to solve them with one. We did that in Algebra 1. But I want you to use two variables or you won't get credit for the problem. All right, this next problem is a distance, rate, time problem. Anne can paddle her canoe 15 miles downstream in 2 hours. The return trip takes 3 times as long. So basically, you have to set up a chart talking about the information. So we have the speed, we have the time, and we have the distance. And two interesting situations here. We're going downstream and upstream. So the speed, we don't know the speed, right? But we know the distance, 15 miles. When we go upstream, again, 15 miles. Time down is 2 hours. Time up, 3 times as long, 6. Speed, that's where we're going to use our two variables. When you're going downstream, you have the rate of the paddling plus what's helping, the current. What happens when you're going upstream? You got how fast you can paddle against the current. So, there we go. Now all we need to do is set up two equations for this. Any thoughts? How about speed times time equals distance? So 2 times x plus y equals 15. And how about this one? 6 times x minus y also equals 15, right? Same distance both ways. Now, you can simplify these and solve them. Eventually, you should get x equals 2.5. I'm going to leave the solving to you. Be careful, don't forget to distribute, and then solve the system. And remember, there's a couple ways to solve the system. You can do it by adding and subtracting, or you can do it by substitution. Use what you like best. Be careful, though. Alright, so here we have a mixture problem. We're selling mixed nuts, $4 a kilogram, with raisins, $3.25 a kilogram. A mix of 15 kilograms costs $3.60 for a kilogram. How many kilograms of nuts were used? So basically, again, we're going to use two variables, and what are we talking about? We're talking about nuts and raisins, right? And we don't know how many nuts, kilograms of nuts, or how many of raisins we have, so let's call that our x and our y. We know the nuts cost $4. We know the raisins cost $3.25, and we know that we're going to have a mix that sells for, what was the mix selling for? $3.60. Yeah, $3.60. Now, we know that we have 15 kilograms, so the first equation, x plus y equals 15, will work. And then the x times $4 and the y times $3.25 and the $3.60, how many kilograms do we have in that final mixture? 15. So there is the second equation. I would call this one 4x plus 3.25y equals, and 15 times 360 is 54. And now you have a system of two equations and two unknowns, and you can solve it. My guess would be multiply this equation by -4, then you can get the x's to cancel, and in the end you should get y equals 8 and x equals 7. See if you can finish this yourself and get those answers. X equals 7. I guess you can't see that very well there. X equals 7. So